Hey, sorry about I was muted. All right. Uh, Thank you, folks, for being here today on a Thursday evening. I'm Ragunath, and I work as an independent consultant with startups mostly. And I help them with extreme programming, test-driven development, and architecture. These days, I've started spending most of my time focusing on legacy code bases. So if you have a code base where there are like no tests and that is complex and difficult to work with, so that's the area that I'm specializing right now, and I'm helping people reclaim legacy code bases. So that's my area of focus. Today, what we're going to talk about is we're going to talk about building robust software using Kotlin. So when we talk about building robust software, more often than not, software fails, and that's something that's expected when you're building software, right? So just because software can fail doesn't mean that we have to strive building software that doesn't fail, right? So here in this talk, we're going to talk about a bunch of ideas, mostly ideas from inspired from building the TCP protocol and also using ideas from the functional programming world. And when we talk about building robust software, it's not that we get one thing right and then that's going to help us build like robust software, right? So if you want to build robust software, then there are like a lot of things that we have to get right. It's not just one thing. And we will be talking about a lot of different ideas, but then in this talk, we'll start with one idea, and then later on we will, uh, in subsequent talks, we'll discuss more ideas, right? So in this talk, I just want to focus on one thing, which is how do you write code that communicates well with other team members, right, and also other parts of your system. But then it focuses most on the human element. So before we go ahead, the idea behind this talk is to show you some code examples and then see how we can change those examples to come up with a system that's more maintainable and more robust. So the first thing that I'm going to talk about is how do you make API calls and then how we interact with external systems. If you look at this code sample, we have an interface called Accounts API, and then it takes in a couple of, it has a function that takes in a couple of parameters, and then it also has a return value, right? So for simplicity reasons, we're not going to deal with asynchronous code, but then you can take these ideas that we discussed and then use it in asynchronous code as well. So right here we have a function called sign up, and then we also have a couple of parameters that are being passed into this function. We have an email, and then we also have a password. And if you look at it, we have a response. And for Kotlin, people like developers who are already working in Kotlin, the question mark signifies that this is a nullable type, right? So if you're going to call this function, you can either get a valid response or you can get a nullable type. So now, if you take a look at response itself, one thing that can happen with response is it can successfully create a user account and it can return a response. It can return null. It could return an exception. It could also return a different kind of exception or even a different kind of exception, right? So it can also return different kinds of exceptions, but these exceptions have meanings attached to them, right? Which is not really evident with this. So this is like the happy case. So it's something that we look forward to, and it's likely the most common scenario when you're dealing with this API. If the API returns null, in this case, you or me, like we don't really know what's going on here, right? It's just returning a null value, but then we don't really know.
Raghunath, sorry,
Yeah.
sorry to interrupt you. So the screen, we are only able to see the black screen. If you can please reshare your screen.
Oh, sorry about that. So I'm going to share my complete screen. Can you see my screen now?
Yeah.
All right. So if the API is going to return null in this case, then there's no way for us to understand why it returned a null, right? It's just like a black box, and it's full of mystery. So these three exceptions, we know there is something to do with the connection, and probably the third one is something to do with the framework or the way how the function is being implemented, right? So let's see how we can go ahead and improve this, right? So if you're someone who's going to call this function, you'll be happy if you're going to get a happy case, but then probably you will be confused, and you can also be worried about what this function is going to do. So let's discuss robustness principle. So robustness principle tells that you have to be conservative in what you send, and you have to be liberal in what you accept. And if you design systems that adhere to this principle, then probably the systems that you build will be robust, right? That's what the principle states. The keywords here that we have to focus on is conservative when we are sending stuff, and being liberal when we are accepting things. And when you talk about functions, the things that we are accepting are the function parameters, and the things that we are sending out is the return type itself. So now if we apply this principle, how are we going to change this function, right? And one way we can do that is to introduce a new type called sign up response. So this may not look like a significant change at this point, but then you can already see that this is no longer a nullable type, right? So it's a type that's always present. And now, if you go and look at how sign up response should look like, right? So sign up response is typically telling us there is a contract between the client and the server, and our attempt is to create this type and then make that contract more explicit.
Sorry to interrupt again. So since we lost you in the start uh, because it wasn't shared, can you please go through the slides again? I'm extremely sorry for asking this, but yeah.
Oh, that's fine. So where do you want me to start with?
So I think you can go ahead from the start itself
From the
because the
beginning of the
slides.
talk?
Yeah, like
All
at the
right.
start. Thank you so
Yeah,
much.
sure.
Thank you.
All right, that's okay. Yeah, sorry for the tech problem, folks. Uh, yeah, so I don't think like the introduction. I'm not going to do the introduction again. I'm a consultant. I work on legacy code bases. Oh, that's the gist of it. So when we talk about building robust software, we don't. It's not essentially getting one thing right. So if you want to build software that works all the time, then we have to get a lot of things right, right? And in this talk, we're going to take and discuss only one idea, and then there are like a bunch of ideas that I really want to discuss, but then we will do that in other talks. So the way how we're going to start with the idea of building robust software is.
Ragunath, I'm extremely sorry. The screen is not visible again. I don't know why it is happening. So I'm extremely
Oh,
sorry.
that's
Can
so weird. Uh,
you please?
I, I don't know why this is happening, but is it okay if I just do this instead of like sharing the screen like completely?
I mean, can you just try sharing the screen again, complete screen, like entire desktop that you have? I will
Yeah, that's what
help you.
I'm doing already. I'm sharing my entire screen. Uh, can you see
Yes.
this?
Yeah. We can go to the presentation mode, right? I will. Yeah, we can see this now.
Can you see this now?
Yeah.
Can you
We
also
can go.
see this when I'm transitioning back and forth?
No. Can you do the transition once?
Right now, can you see it?
No, I cannot see the transition. So.
So I think it would be just better to like do
Yeah,
this.
now I saw. I was able to see. Can you go again?
All right. How about now?
Okay. Again, it is blank screen. I'm not sure.
Yeah, I think there's something to do with StreamYard because I've been trying. I'm sharing the entire screen, but it doesn't really show the entire screen.
So it is in the
Mm,
presentation mode, but still it is not showing the presentation.
yes, that's correct. So I'm sharing my entire screen, but then for some reason it doesn't work. I don't know why though.
Okay. Maybe can you switch once, just to see if the screens are changing?
Yeah,
Are you switching the screen?
yeah, I am switching the screen. Can you see my screen?
No. I mean, we can see your screen, but not the switching of the screen.
Oh, that's so sad. Um, Probably has to do something with my machine or StreamYard, but can't really tell.
Okay. Uh, you are sharing the desktop itself, right? Like the whole desktop, not just the
Yes,
presentation.
yeah, that's correct. I'm sharing the entire screen.
Okay. Can you switch the desktop? Like add another desktop and add your presentation there and share it. Try sharing it.
Uh, like this.
Actually, we can't see
So,
anything you're doing apart from the screen that you're sharing right now.
so it's okay. Let me try one more thing. Share the screen. So sorry for all the folks that are here. Uh, so let me. This is StreamYard. Choosing entire screen. Uh,
Uh, yeah, we can see the screen now, but can you just try switching it like again?
does this work?
Uh, Probably don't share the presentation, maybe.
Yeah, I think we'll just do the keynote thing instead of the
Yeah,
presentation mode.
yeah,
I
and
think
then
that's
we can
more.
go into the code thing that you want to show.
Yeah. All right.
Okay, okay, thank you.
So yeah, so sorry for this. I don't really know. It's completely random. Uh, all right, let me do this. Uh, so the idea behind today's talk is to share a bunch of ideas that are well tested, and these are some of the ideas that you can go back and apply at work, right? Like even probably tomorrow. So those are like the kind of small ideas that we're trying to do here, because building a robust software requires a lot of things, right? So for example, you may have to write tests, right? And that's not something that you can do like right away. In order to build robust software, we need to work on a lot of different things, and this is the first step towards that goal, right? So the first example, what we're going to discuss today is we're going to look at an API that interface that can help us make API calls, right? So if you look at this interface, it's a very simple interface. It has only one function in it. And then if you look at the function itself, it's going to take the email and the password, and it's going to return a response object. And if you look at the response object, it's a nullable type. So if you're calling this function, you can either,
Sorry, just a minute, Raghunath. Are you sharing the code part right now?
yes, I am.
Okay.
Is it not visible?
Yeah, it is not visible. Right now, we are able to see the presentation part, but not the code part, like whatever you are talking about. You are sharing the
So
IntelliJ or something like the code thing.
yeah, I'm sharing the entire thing. Wow, this is super random. Uh,
Yeah, maybe only you can try sharing the code, only the code part instead of entire desktop. I'm not sure why it is not switching, but yes.
Hey, can you see this right now?
Yeah, accounts API we can see right now. Yes.
Okay, let me just give me one sec. So now if I switch this, can you see the code as well?
No, we are just seeing. Yeah. We can see. Yeah, right now we are able to see this. Yes, it is working.
All right. Okay. Uh, all right. So this is an interface, and then it has one function that takes a couple of parameters. So the function is called sign up, and then we have an email and then password, right? And then if you notice, this function's return type is a response, which is a nullable type in Kotlin. So let's go ahead and take a look at what response looks like, right? So if you look at the response nullable type itself, there are like a bunch of things that can happen. So one is it can either successfully create a user account and then it can return a response for you. Then it can also return a null, but if it's going to return a null, then I have no clue what that means, right? And then probably if you are the one who's calling this function, chances are you also may not know what null means. And then we also have cases where we can get different kinds of exceptions depending on the kind of network stack that we're using. So let's see. So this is a case that we discussed in null and different stuff, right? So if you're going to call this function, or even if I'm going to call this function, I'm probably going to be happy if it's going to give me what I want. A little bit confused if it's going to give me a value that I did not expect, and really what do you call it? Afraid if it's going to throw random exceptions at different points in time. So when you talk about robustness principle, this is what it means, right? It says be conservative in what you send and be liberal in what you accept. So what we're going to do is we're going to take this principle and then we're going to apply this at a function level. The keywords for us to look into is conservative and send, and then liberal in what we accept. If we take that idea and then apply this to a function signature, things that we accept are the function arguments, right? Which is these are things that can be liberal with, and then we can also get the things that we're sending out is the response itself. So when we say be liberal in what we accept, but then it be more conservative in what we're going to send, so we're going to try to make a little bit of improvement over here. So the first thing that we're going to do is we're going to change the return type from response, the nullable response type. So now when you have a sign up response, now these are all the things that the response can give us, right? So it can either successfully create a user account. We can tell us whether the email is already registered, because if the email is already registered, then you should not be able to register a new account again. Then it can also have validation errors based on your email or password, and then you have connection errors on the client side. You have server problems like 500 series, and then you can also have unknown error codes, right? Sometimes it can not be relevant to your domain or like your server itself. So what we're going to do is we're going to take all of these ideas and then we're going to encode them into the return type itself, right? And how are we going to do that? Kotlin gives us something called as a sealed class, and sealed class is a way for us to create restricted class hierarchies. So when I say restricted class hierarchies, usually when we talk about inheritance, if you have a super type, there is no way for us to limit how the hierarchy can look like. So anyone who can get access to the super type can go and implement their own type. But with sealed classes, we say, hey, you know what? Like the class hierarchy that we are proposing are going to be compile time only, and then no one else outside the code base can add more types to the class hierarchy itself. So that's what we're going to do. We're going to use sealed classes to encode all this information into our type. So here you have a sealed class called signup response. And then we're going to encode each of these ideas into the response subclass. The first thing that we have is account creator type. Then we also have an email already registered type. We have an input validation failed type. We have a client-side connection error. We have a server error. And then we also have an unknown error that gives you the status code and possibly the response body if the error has one. So now that we have encoded all these possible responses into the type, we can go ahead and use it. In case if you're going to call this API with two parameters like John Doe and John at example.com, you're going to get a response object. But then what you can go and do is use a when clause on the response itself. So now when we're doing that, if the account is created, we're going to save the user ID inside the application itself. If the email is already registered, then we're going to show a proper response to the user saying that, hey, you know what, we already have this email, probably you are trying to log in, or maybe use a different email ID if you wanted to create a new account. And then we have a bunch of responses for input validation, and then we have a client-side error, and then the server error, and the unknown error, we handle it at the same in the same way, right? We're going to say, hey, you know what, just try this sometime later. And if you look at exhaustive, this is sort of like an extension function that I wrote. If you're not going to use the return value from your when block, in this case it's unit, when is not going to throw a compilation error telling you that you're not handling all possible cases with your class hierarchy, right? So when you do exhaustive, this is like a hacky way to ensure that the compiler catches scenarios where you have a new type, but the when is not able to, it has not implemented that type, right? So this is going to make into the language proposal. So until now, you can either use a compiler plugin that can do this for you, but then right now it's just like an extension function that I've written as a hack. All right, coming back. So this is what we have, right? So now we make an API call, we get a response, and based on the response, we make a decision, and we make sure that all this idea is communicated to whoever is looking at the piece of code. So now if you are going to call this function, you're probably going to be happy and peaceful because this function is not going to throw any surprises at you. So what have we achieved here? So one thing that we have achieved is certainty. So we don't really have like a null value, for instance, or like we don't have an exception that's being thrown here. So whenever you're calling this function, you know for a fact that it's going to return a value, regardless of the situation, right? It's not going to throw an exception. It's not going to give you a null value. And then now you're conveying all the business idea that matters to your use case through your code. And then you've also improved readability, and we are also representing all the errors as data. So when we represent errors as data, that becomes much more easier because your tests can look a lot more simpler and a lot more elegant. So we've learned something called as total functions. So total function is an idea from the functional programming world. And since Kotlin is like a multi-paradigm programming language, you can use functional programming constructs as well as object-oriented programming ideas to build your solutions. So this idea, the one that we're looking at right now, is making use of this idea called total functions. So what does a total function mean? A total function is simply a function that will give you a valid return value for any argument, right? So if you're going to call this function, the function is not going to throw an exception. It's not going to like go into a loop, or it's not going to give you a null value. It will always give you a value. That's what a total function is. And total functions are easy to work with because the return type has a very specific contract, and that contract is well communicated to people who are maintaining the piece of code. The opposite to a total function is called a partial function. So a partial function has certain characteristics. So I'm going to run through this. And these are all the things that are part of a partial function, right? So if a function is partial, it may or may not return a value, right? It may or may not return at all. It can throw an exception, or it can also crash your system. So that's what a partial function is. So if you want to build robust software, what we want is we want to lean towards total functions and then minimize the amount of partial functions that we write. So that's an idea that we're taking from the functional world, and then we're trying to implement in our day-to-day life as a programmer when you're building software. So this signature is that shows as a partial function. So it's still the sign up thing, but then it returns a response, a nullable type, right? And if you look at the total function right now, it's not like a big of a change, but then you can already see the benefits that it's giving us, right? So the sign up response is a total function because it's going to return a value regardless of the situation that the system is in. So we have learned total function, and then the other thing that we have learned from the functional world is called algebraic data types. So an algebraic data type is a type that is formed by combining other types. So if you look at sign up response here, we really can't create an instance of the sign up response. Think of it as an abstract type, but then you still can't create anonymous classes for a sealed class. And the only way the sealed class gets its meaning is through the subclasses, right? So if you look at sign up response, the sign up response itself gets its meaning through all the classes that inherit from it, but it can't really have an instance on its own. So far we have learned what total functions are. We have learned what an algebraic data type is and how you can use Kotlin to create your own algebraic data types. And then we have also learned the idea of robustness principle. So where do you use it? Where do you use this, right? So one of my favorite places where I strive to use total functions and sealed classes or integration points. So these are points where points of communication between subsystems, or it can also be points of communication between different teams or also different systems, right? It can be either external or internal. And I also like to use them while refactoring when you're building anti-corruption layers, because this is a place where most of the meaning and context is lost. And when you start using algebraic data types and total functions, these are places that are critical for you to transition to a newer system, and also helps people from different teams understand what's really going on, right? And sometimes it's so tempting to use this everywhere. We can use, like, for example, in databases and file systems, but unless and until these form the majority of your system. So for example, if file systems is something that you work with, and the kind of software that you're building with constantly interact with file systems, then probably it makes a good idea to build it. Otherwise, it's okay to write code the way you normally do. So we're going to take these ideas that we have learned from the example one, and then we're going to apply them to a different example right now. So let's take a look at this function. It's a very simple function called divide. And then it takes two integers, a dividend and a divisor, and then it gives us an integer, right? And like most of you have guessed, this is already a partial function, because when you call divisor with 0, then it's going to throw an exception, right? So it's going to throw, hey, you know what? It's an arithmetic exception, divide by 0. So let's go look at the robustness principle and then figure out what's going on. So the principle tells us you have to be conservative in what you send and liberal in what you accept. So let's take these ideas and then the same ideas that we applied in the previous example, and then let's try to apply them here and then see what happens. Here I'm going to take this function and then I'm going to say, hey, you know what? I'm going to be liberal in the kind of inputs that I'm going to accept, but then I'm going to be more conservative on the kind of output that I'm going to give. So here we're going to create a new type called quotient, and the function itself checks if the divisor is 0, and if it's 0, it's going to return infinity. Otherwise, it's going to return a result, which is basically the dividend by the divisor. So let's go take a look at how a quotient looks like. So if you look at quotient, it's a sealed class again, same ideas from the previous example. Then we have infinity, and then we have a result. So now you may already be thinking this doesn't seem right, right? So what's going on here? This doesn't actually fix any problem that we're trying to fix. So the first thing is, if you're a caller, then you are supposed to check the type and then handle both the cases. And the second thing is, if you call this function and if you're going to get the return value, you can simply pass the return value downstream. So if you're going to pass it downstream, whoever is going to consume that value has to make that check, right? They have to check if it's infinity or if it's a quotient. So that's also not going to fare well, right? So it's just like taking this problem and then moving it elsewhere. Can we do better? So if you go look at the robustness principle again, we're saying be conservative in what you send and be liberal in what you accept. But then that's not taking us so far. What if we can change this idea and then say be conservative in what you send, but also be conservative in what you're accepting, right? So when we take this principle and then tweak it slightly and then go look at this again, now you can see, okay, there's a divide function, and then we have a dividend, which is an integer, but then we have a divisor, which is of a new type, which is a non-zero type, right? And then now if you go look at the return value is an integer, which means your downstream consumers are going to be happy because they know for a fact they're going to get a valid quotient. So we just go ahead and do dividend by divisor and then dividend number. So that's what is happening here. Now let's go back and take a look into this type. So if you look at the integer type, you can see there is a 0, which is still extends from integer, and then you have a non-zero value. And then right now we also are looking at an object that says companion object that has a factory function. So the responsibility of the factory function is to take in an integer and then give you a value, either a 0 or a non-zero value, right? So by making this change, we are ensuring that callers of our function can never pass a invalid value for the second, uh, divisor parameter, right? There are different ways to do this. So one is you can obviously use a seal type, which is the safest way. The other way you could also consider is to just create a new non-zero type and then validate the input in the init block, right? But then that has interesting implications, because you're just moving the validation logic into your init block, and when you do that, you'll probably throw an exception saying that this is not going to work, right? So what essentially happens when we make that kind of change is that we are moving something that is a compile time error to a runtime error, which is much more dangerous, right? So a single class approach is much more easier and more fail safe, is fail safe, because you can catch these errors during compile time. So here, yeah, it's just validating and then give you a 0 or a non-zero type. So here, this is how we use it. We say integer.from, and then we pass in an integer value. If the divisor is not 0, then we're going to divide without any problem. Otherwise, we'll fail fast, right? So there is a section on how we're going to deal with the fail fast part. But then for now, all your callers, it's their responsibility to give valid values to your function. So now we're going to take a look at the original version and the tweaked version. So if you look at the original version, the inputs are liberal, the output is conservative. And then if you look at the divisor will allow you to pass in invalid values, right? Which means the function is going to be a partial function and it's not going to be a total function. And then you get a quotient, right? So now this is only placing more burden on people who are going to call your function. So the second thing that we're trying to do here is we're being more conservative in the inputs. So here the divisor is a non-zero value, so it is impossible for someone to pass in illegal values to your function. And the return value is something that's easier to work with as well. So right now we've learned how to tweak the robustness principle and then make use of it to create systems that are like more fail-safe. And also sets expectation for your users. So where do you apply? So apply this mostly with your domain objects and inside things in your system boundary, because that also encourages other developers to take an approach that help them define boundaries more clearly. Third example, we're going to talk about defensive programming a little bit. So defensive programming is what people do when they don't really trust the system, right? Interestingly, a couple of years ago, I was working with a person, and this person was writing like a lot of defensive calls. So what he was doing was he would look into all his, so the way how he would do it is whenever he was making call to a external server, all his fields from the response were nullable, right? So they were all nullable objects, and then he would perform null checks on each of these values, right? So I tried to ask him like why he was doing this, and then he was saying he did not really trust the team that maintained the API. So he used to make sure that all fields are null or not null before he processed them, right? And then he also made sure that the application did not crash, right? So this is both a good thing and a bad thing, because defensive programming, people do defensive programming when they really care about the system that they build, right? But then it also makes you also have to make sure that you're being defensive at the right level, and you're using the right strategy to be more defensive, right? So if you're not being defensive at the right level, it sucks up a lot of energy, and then also ends up building systems that are complex, more complex than necessary. So how do we do defensive programming, right? So how do we make that easy for people to work with? And if you're a developer who worked with like the file API a lot in the Java SDK, then you probably know it's quite clumsy to work with. It's not easy at all. And most of the time, when you're working with an API like the file API from the Android from the Java JDK, you will probably be writing a lot of defensive code. So and this defensive code is also like a lot of duplication, right? So let's take a look at an example where we use this file API. So if you look at this function, it's called count files, and then we have to pass it a directory, right? And if you look at this first parameter, if the function name is not clearly defined, then we may be confused to uh, pass in what should go in, right? So we don't really know what to pass in if the file name does not say the parameter name does not say directory. And the second parameter is basically an extension. So from the function signature, we can safely say, if I'm going to give this function a directory, and then if the function has a certain extension, I'm going to count that function, right? So now this function obviously returns an integer value. And now what happens is I am going to take a look into the implementation of the function. So the first thing is basically a defensive check. So we're going to say, hey, if the directory exists and if the path exists and the path is a directory, then proceed with the rest of the body. But if the directory does not, if the path does not exist, or the path is not a directory, it returns 0, right? So in this case, we don't really know what 0 means. We can pass in a sentinel value like -1, but then that does not fix the problem here, right? Because if you're going to pass in 0 or -1, why did we get -1? Did we get -1 because the directory does not exist, or is it an invalid directory, right? In both cases, we're not giving the caller enough information to deal with the problem at hand, right? And chances are, if the programmer also does not trust this API, they would also be doing this checks before they call this function, right? Which is basically duplication of effort. And now we're going to say, hey, if this is a directory and if it exists, we're going to list the files. And if the name ends with the extension, then we're going to count it, and then otherwise we're going to give it a 0, right? So that's the essence of this function itself. How can we make this better? So we're going to apply the tweaked version of our robustness principle, and then we're going to say re-implement the function. We have count files, and then now the directory is taking a valid directory, right? So we have a type that explicitly models something, and unless you give it a valid directory, you really can't call this function, right? So that's what we're doing here right now. And the moment we know that we're going to getting a valid directory, all we can do is we can just go ahead and then do what we are supposed to do without performing these checks redundantly. And if you have a system where you're constantly working with file systems, and if you're also finding you and other developers doing similar checks to make sure that the file exists or that the directory exists, you can model this as part of your domain API, and then ensure that all the APIs have a certain amount of guarantee, right? So in this case, if we want to give it a valid directory, it's pretty sure if it's not a multi-threaded application, then the directory is going to exist. So here, let's say we have a sealed class again, and then it says valid and invalid. And again, we have the same pattern where we have a companion object and a corresponding factory function. The factory function takes a path, and then we are saying, hey, you know what, if this is a valid directory, and then we're going to give it if it's a valid directory, then we're going to give the type valid, otherwise we're going to go invalid, right? So if you look at the else part, where we say this is not a valid directory, we're just saying it's invalid, right? It doesn't really communicate why it's invalid. Is it invalid because it doesn't exist, or it's not readable, or it's not a directory itself, right? So the richness of your invalid cases really depends on your domain that you're working on, right? So if your domain needs this to be a lot more richer, then you can create subclasses for each of these individual classes, or you can also create a enum along that you can pass as a parameter with your invalid type, right? So it really depends on the domain that you're working on. So you can be picky about how much amount of information that goes into your algebraic data type. So that's the implementation. And now you can say, hey, if this is the directory, and if you're going to give it a path, If the directory is valid, then you can go ahead and do whatever you want to do. Otherwise, you can just go ahead and fail fast, right? So what have we learned? So this topic was mostly about how the right abstract data type and the right kind of API design can protect yourself and all your fellow developers from making unnecessary and duplicated defensive calls throughout the code base, because those are like really hard to catch. You can still write lint rules, but then if you can build that kind of guarantee into your type and your domain, then it pays off when you can model appropriate types that can provide this guarantee to your callers. Again, you can go ahead and use this wherever you're using like a lot of defensive calls. That's one area where you can model them into appropriate type. So this is like more like a high-level approach where we see how this comes into play when you're building a larger system. So most of the time we end up modeling values as primitives, like use a big decimal for currency, use strings for usernames and emails. So these have interesting design implications. And we're going to see how we can use appropriate types and what kind of implications that they will have on the design of your system itself. And this section is all about failing fast, right? So in the previous examples, we've been talking about how do you fail fast, but this is what it's going to show you how it's done. I'm going to take an example from a GUI pattern. So basically, if you've worked on GUI systems, then you probably are familiar with this architectural pattern. But if you're not, don't worry. All you have to know is it's like a bunch of boxes and how the data flows between these boxes. So even if you're a backend developer, you can still make use of these ideas and then go apply them in your systems. So to give you a high level idea, usually when you use the MVP pattern, the view is usually a very dumb thing. So it's very passive, and its responsibility is to get inputs from the user and then show responses to the user. So that's where we use a view. And you have a presenter. That's it's the responsibility of a presenter is to get these like coordinate the view and the model itself. And model is usually where all your business logic is. So if you look at this, these two components are usually like coordination logic and business logic heavy. So these are more complex, but then your view relatively contains like zero business logic. So the way how these components communicate between each other is when something happens on the view calls the presenter and then tells, hey, this is the input that I need you to process. And the presenter can in turn go back to the model and then tell, hey, you know what, can you process this for me? And the model processes that information and then tells the presenter, hey, I've done what I can do, and this is what you have to tell your user. And the presenter can go and present that user to that information to the user. So that's how usually MVP is done. So now let's talk about a login screen where you have username, right? So let's say we have a username and then we are saying, hey, you know what, the username is a string and I'm going to give it to the presenter. And the presenter is going to say, okay, now there's an input, I'm going to give it to the model. And the model is probably going to validate that input for you. And then if there's a failure, it's going to tell the presenter, and the presenter will show the appropriate failure to the view, right? So what I want you to pay attention to here is you get a username, which is a string from the view, and then it's being passed down to the model. And the model says, hey, something is right or something is wrong. And then it communicates that information to the user, right? So the data travels all the way from the view to the model and then back to the view itself. So what is happening here is we have data, which is your username, and then we have the logic, the validation logic, which is the behavior that is present inside your model, right? So we have the data and behavior in two different places, but the idea of object-oriented programming is to have data and related behavior in one place. So us having data and logic split in two different places itself is going against the spirit of object-oriented programming. So how do we fix this? The way we can fix this thing is to model, have an appropriate type for the username, right? Instead of modeling the username as string, we can model it as its own appropriate type. So we have a valid type. We have a seal class, which is username, and then we have a valid type, and then we have an invalid type, right? So the invalid type can contain a set of reasons on why the validation on the username failed. Again, we go back to the same pattern. We use the factory function inside a companion object. It takes a username, and then if it is valid, then it's going to give you a valid type, or if it's invalid, it's going to give you a invalid type. The reason is just one reason, which is it contains an invalid character. So now let's go back and take a look at this again. So now the username has a rich type, and then it has two subclasses, which is invalid and valid. In this case, if the view is going to create a username and then it's going to pass it down to the presenter itself can attempt to construct the type. And if it fails to construct the type, then it's going to tell the view right away that, hey, you know what, I really can't construct this type. Maybe this is a failure that you have to look into, right? So right now, instead of passing down this value from the view till the model, we are short-circuiting it and then handling it right away from the presenter itself. So now, instead of like the previous case where we had to like do a complete loop, now we can shorten the loop and then fail really fast and then ask the user to fix it as quickly as possible. So then what happens now? So this means the presenter will only allow valid usernames to go down the stream. So if your model is going to work with the username, then it no longer has to worry about other edge cases, right? Because the data that it gets itself is a data that it can trust. And any data, and if the model decides to pass it downstream to a different subsystem, it doesn't really have to worry about the validity of the type, because the type is always valid at this point onwards. And in case if it's an invalid type, it's being filtered right away in the presenter itself, which means invalid types will never get through the system, and you have a guarantee that any value that you get is valid in the system, right? And you're already filtering all the invalid values as quickly as possible by failing fast. So here we also learned how to use just the type system from your programming language, here in this case Kotlin, to enforce control flow between data components, right? You're saying, hey, only valid data can pass through, and invalid data can never get into the system. And we're failing fast, and we're also reducing coupling between components, because now even if the validity of the rules change, then you don't really have to make changes to your model. All you have to do is to make those changes to your username type, and possibly to your presenter if you're going to add new types of error conditions or constraints to the username itself. So again, apply this to places where you're using the same domain type across multiple reasons. So unless you can justify that, hey, I don't need this, just go ahead and use it. So if you look at the impact of the kind of ideas that we've discussed so far, you will know that you're like a lot more confident when you're dealing with certain types, and you're also a lot more confident when you're calling certain functions in your public and private APIs. We're treating errors as first-class citizens. We are no longer afraid of handling exceptions, or we're no longer afraid of null values, because all of that information is encoded as a rich domain object. Again, reduced range of motion for your data from your point of origin. So failures are handled pretty soon, and only valid data types are passed down your system. Then if you are using different kinds of architecture patterns, one of the patterns that I really like is the pattern where you have a functional core and then imperative shell. So the ideas that we have discussed in this thing, those are in this talk. Those are applicable to your functions, but then you can take these ideas and then also extrapolate them and then create an architecture that has a functional core and an imperative shell. And then we're having a focus more on towards data, and then we're also making sure that the boundaries between components and model in terms of values over function calls, right? Which means your tests are going to be a lot more simpler, because it's much more easier to recreate values than to create function calls or like make your stubs or your mocks throw exceptions. And now primitive obsession is a code smell, a constant code smell that most developers, especially in your like junior and mid-level engineers, come across. So that's something that you have to be more conscious. And now the ideas that we discussed here will help you remove primitive abstraction from your code. And also when you're creating new domain objects, you can sort of actively avoid creating types that are primitively obsessive. Then also reduces defensive programming because your most of your defensive programming will be done within your factory functions and more of or layers where data originate, right? So that means you would be doing a lot less defensive programming, and even if you forget, the compiler will catch it for you. Again, the last benefit is about promoting value-based testing over behavior-based testing. So the number of mocks and stubs that you're going to use in your test will drastically go down because right now you can use values to model different conditions in your system. So this is the summary of whatever we looked into today. So we looked at the robustness principle in its original form. So we are being liberal in what we accept, and then we are being conservative in what we send. We also talked about total functions. So total functions are things that functions that can work all the time without failure. And then we have algebraic data types, which is how you use a composite type using the Kotlin sealed class. And then we also looked at the robustness principle, the tweaked version of it, where we say we are also going to be conservative in what we accept, and we are also going to be conservative in what we send. We also looked into ideas that will counteract primitive obsession and prevent defensive checks. We also saw ideas how we can shape the program's control flow in terms of like a larger system, and then how we can fail fast in case if we encounter invalid data. So that's about it. And if you have any questions, I'm more than happy to answer.
Yes, Ragunath, there are a couple of questions. So I have posted in the private chat. Maybe you can you just go through that thing?
Okay, so we talk about why is the use of this to be avoided. Interesting. So I don't really know where this thing comes from when we say Kotlin thrives on explicitness, and in your opinion, why is the use of this to be avoided? It's not my opinion to avoid this. I'm not really sure if I said that. I'm sorry if I did, but I prefer using this explicitly because it comes in handy in a lot of different cases, right? So for example, if you have a function fixed signature that takes a parameter a, and then you also have a local variable called parameter a, and if you're trying to refactor this, then Kotlin, it's going to be confusing, right? Because you don't really know what you're referring to. So I prefer using this. So I would always use this to refer to a local field or a property. So I don't think that's something that needs to be avoided. It's okay to use this. I'm not really sure if this is coming from a different language where people tend to use a underscore or like a different variable name. But when it comes to Kotlin, that's what I would use. And what are my thoughts on top level bars? So when we talk about top level bars, then it comes to the subject of mutation, right? And when it comes to the subject of mutation, it's sort of personally, I really can't talk about someone else because I can tell you what my experiences with top level bars. I try not to use mutable values in the code that I write, right? So the moment you have mutation, then it adds more complexity to write code because at this point anyone can change the value at any point in time, right? So now you have a value, but then that value is also somehow tied to time. So I prefer using vals and using immutable data or like read-only data structures when possible, and use a copy constructor to make a copy. So I think it should be avoided, but I'm not really sure about the context that you're working in. But to me, top level wars are like mutation in general when it comes to Kotlin. That's something that I try to actively avoid. Uh, So how do you argue that Kotlin helps produce a robust software when everything defined is by default public? So that's an interesting question. The answer to this question is everything is public by default, That means Kotlin is also forcing you to think about the kind of APIs that you're designing. And like I said with the previous thing, if you prefer immutability, then it's easy to build robust software. So yeah, that's about producing robust software when everything is by default public. And also, if you look at the way how API is designed and like how IntelliJ itself is designed, if you're using something like var as a public API or even a private API, IntelliJ tries to actively underline these values. So that way you can know it really looks ugly, right? So that the idea behind that kind of design is to nudge you towards using immutable types and immutable properties in your code. So that's it. Give us some compelling features of Kotlin that helps with robustness of software. Uh, Interesting point. Yeah, I think like the essence of this talk itself was mostly highlighting these things: immutability, sealed classes, using non-nullable data types. So those are some of the things that I think are compelling to use. And even one of the things that I notice is most of the time as engineers, we hesitate to create new types. So what we do is we use strings for everything, integers and things like that. But then right now you have inline classes. So when you use inline classes, the cost of you creating a inline class is virtually zero, right? So what Kotlin is also doing is, hey, you know what? Don't use just a string. You can create a password class, and then that class will literally have like close to zero overhead because the compiler will take care of optimizing it for you, right? So I think inline data classes, immutably by default, uh, and then a default push towards immutability. So those are the things that that are some unsealed classes. So these are some of the Kotlin language features that help you move towards robustness software. So concepts you would like to recommend to start with software testing in order to boost robustness. So testing is something that we want to cover sometimes in the future. So when I talk about software testing, what I usually recommend people is to begin with the idea of object-oriented programming, because the moment you start thinking about design while you're thinking about testing, it helps to create systems that are a lot more testable, which again can help you build systems that are robust, right? Because if the majority of your system is well tested, then you can go ahead and design good like write good tests. So personally, I don't really have like a bunch of resources that I can refer to. So uh, because at least when it comes to testing, most of the things that I've learned are from various resources. It's not just from Java or Kotlin. Some ideas I've picked up from JavaScript. Some ideas I've picked up from Haskell and different languages. So if you are looking for resources on testing, one thing that I would recommend is to go look at this talk called Boundaries. That's a talk that I often recommend. So the talk Boundaries is a very good talk. Where this person called Gary Bernhardt from Destroy All Software shows you different ways on how you can model systems, right? And some of the content of this talk has been influenced through his ideas. So if you go look at the talk, he can talk about like a little bit about design, right? So that can help you a little bit. And the second thing that I would recommend is to go look at this talk by so this course on egghead.io. There is a course on Redux by Dan Abramov on egghead.io. So in this course, what Dan Abramov does is he uses JavaScript and creates a system that is mutable by default. And then he changes the system to convert those mutable types into immutable types, and then sort of shows you how you can rewrite the same mutation logic into immutable logic, right? So that's one course that I would really recommend. It's in JavaScript, but then it's not hard, right? So you don't really have to know JavaScript. I didn't know JavaScript when I took the course, but then the idea to look for is how do you take a system that is mutable by default, and then sort of convert it into an immutable system, right? So this is also a really good course that you can go and look into. And there is one more talk. I'm not really sure if it's by JB Reinsberger or someone else. It's called refactoring to immutability. So that's also a talk where he uses tests to show you how you can move to a mutable system to a immutable system. Yeah, so these are some ideas, and yeah, there's also like a bunch of nice ideas by Sandy Metz. She's an amazing Ruby developer, so she does like a lot of interesting talks on refactoring, writing tests, and testing itself on YouTube. So you should also check her out. So these are some resources that I would recommend for software testing and thinking about robustness. So the most argued things about checked exceptions. So yeah, so I have been having some ideas about checked and unchecked exceptions. Because earlier I used to think checked exceptions are better because Java used to force me to handling these exceptions. But then checked exceptions, so what happens is checked exceptions can make your code look really ugly, right? But then the way how Kotlin does this is if you don't have checked exceptions, your code could fail at compile time. But then what they're encouraging you to do is to make sure to handle all these cases as much as possible, right? Which means you probably have to write real tests that can simulate these failure conditions. Or in cases where you can't really do that, you probably have to rely on runtime exceptions, but model your domain in such a way that you have algebraic data types that can represent each of these runtime errors. Yeah, so that's the thing. So now that you know like your functions can fail, then which means you have to focus more on these failures and then model them as appropriate domain errors. So do I recommend sealed classes used as response types need be made generic? That really depends on the kind of problem domain that you're dealing with. Personally, always settle on an idea that's simple to explain. In cases, if you think, so I don't really know where this is coming from, but if this is an idea that you're asking for to handle error cases in network layers, uh, probably it could be a good idea, probably not. But then it really depends on the kind of domain that you're dealing with. So personally, the way how I would approach this is, what do you call it? The way how I would approach this is really like try writing an implementation using generics and write an implementation without generics and then see how they compare against different cases. And if my domain asks me for a generic type, then I would pick that. Otherwise, I would not pick that, right? So most of the time, I don't really have answers for all the questions, right? Because context is something that is very different for different scenarios. So most of the time, I end up writing parallel implementations, try different things out, and then scrap the one that doesn't work, and then quickly refactor the one that works. Some idea about coroutines. I'm really sorry that I'm not the best person to answer coroutines. So theoretically, coroutines are easier for people to understand because what you can do is you can take your imperative code. So you can take your asynchronous imperative code and then make it like synchronous imperative code. That's the benefit, and it also has a much lesser learning curve. For me personally, I still use RxJava, and I'm not recommending you to use RxJava because that's something that I've invested in, and most of my clients still use RxJava. But I am still looking to transition to coroutines, right? And I think coroutines has like a lot less accidental complexity than RxJava. So RxJava is a tool that caters to some specific cases, but I think like most of the cases people won't need RxJava, right? I'm still using RxJava, but I think like that's something that I need to move away from. But I'm not really the best person to like answer about coroutines at the moment. So let us know about MVVM pattern. So when we're talking about MVVM pattern, I think this is coming from Android. So I'm going to give you my thoughts on MVVM on Android. So when we talk about different architectures like MVP, MVVM, or whatnot, uh, so the architecture itself, depending on the kind of libraries that you use or the kind of platforms that you're working on, they give you some guarantees, right? And in this case, when you talk about MVVM, what MVVM tells you is it's basically telling you if you use these libraries, right? Like if you use live data, if you use view model, if you use X, Y, and Z, then if something changes, I'm to update the UI, right? So that's the guarantee that you're getting. So basically, like the way how I look at MVVM is you have a stream that can update automatically, which is your mutable live data, and then you have a view that gets automatically updated, and then you have a notification whenever a data changes, right? So basically, there is a traditional way to do this. It's called callbacks. So you can write a callback that can notify you if something changes, right? So the entire MVVM thing, it's my personal opinion, is if you use A, B, C, and D, I'm going to keep your UI in sync with the model, right? I, I think like that's a lot to pay for just to get updates. I can just go ahead and use callbacks using that, right? Say for example, if you use Redux, Redux can still give you this kind of guarantee. And if you want to sync it to the UI, you can still go ahead and use view binding, right? So for me, it's sort of an overkill, but then that's my personal opinion. But in terms of community, in terms of platform support, Google gives you a lot of things, right? I think like that's a lot more discussion to have. But then one thing that I will always say is if you're going to buy into an architecture like Redux or MVVM or MVP or whatever, you are probably going to use a library or a framework and take a closer look at what is the guarantee that this library or the framework is giving you, right? And based on the guarantee, it's up to you to decide what you want to do, right? Say, for example, MVVM is not the best architecture. I don't like it personally. But then if I'm going to work with a client and then they're like 10, 20 developers, I'll probably do MVVM because you don't really have to train people on doing MVVM because there's like a lot of article available out there. There's like a lot of community support. There's Google behind them, right? Not necessarily the best architecture out there, but then probably something that is well supported in the community. So function do something input of input type want any is a good example of conservative and send liberal will accept. Also, if you're returning any, that means you're not being liberal, right? Because when you're saying any, that means you're being very liberal in what you're sending, right? So your input is, say, for example, you're saying my input is going to be constrained, but then now I can send anything. So which means this causes coupling. For example, if do something is going to return a cat and a dog, and now all your callers need to know that it's going to return a cat and a dog, right? And any means it's going to be any. So your callers should not only know what to pass in, but then they also have to know everything that they have to get out, right? Get out of the function. So if I'm going to add a car and a bike in addition to cat and dog, then now you have four different types, and all the callers that previously worked well may fail now, right? What if I remove cat and dog and then just replace it with car and bike, right? In that case, all the callers are going to break because they have no idea how to handle uh, car and bike, right? Because they were only expecting cat and dog. So that's not a good example. So when you say uh, be conservative in what you send, that means you're going to say this is only going to give you an
Uh, Ragunath, are you able to hear us?
like refer you to the Kotlin Java interop at the moment. Uh, yeah, but I really can't tell you something at the top of my head. I'm sorry. So can sealed classes written in Kotlin be consumed in Java? Yeah, I think why not? You can still consume sealed classes in Java. So basically,
Okay, sorry, I think Raghunath has some issues, network issues. So we lost him. Probably he might be joining in a minute. Let's wait for that. Or else I think he has already covered most of the questions. Yeah. Sorry for the network issues, guys.
Hello.
Yeah, yes, Raghunath, we are able to hear you.
Okay. Okay, sorry, I dropped off. I think the last question was, can seal class written in Kotlin be consumed in Java? Yeah, I don't see a reason why it can't be, because seal classes are usually a abstract type, and the compiler. The thing is, you won't get your exhaustiveness. Like if you are using a seal class in Kotlin, you can always do a when on the seal class instance. But then if you're going to do it on Java, I don't see how you can access it. Uh, yeah, I am guessing that we are out of questions, and we're
Yes,
also out of time.
yeah, we have covered all the questions that were there. Just that
All right.
maybe can you go through like the tips and coaches on writing libraries in Kotlin? The question that was just
Okay.
before.
All right. So for this one, so what are all the tips? So I really can't like think about anything. I think like the Kotlin Java interrupt would be a better thing. But what else? What are the things that you may have to look into? I think like one of the things is API, how they look like. So if you're going to have top level functions in your Kotlin file, then the name is by default takes the name of the file and with a KT, right? So for example, if you have a bunch of functions inside file.kt, then the corresponding Java class would be file kt class, right? So in that case, you may have to explicitly give a specify a annotation that will create a class name to be consumed inside your Java class. That's one thing. And there's something to do with companion objects. And I'm not really sure. Yeah, and companion objects, and probably lose null safety when you're using consuming APIs from Java. So that's one thing that you may have to look into. I think like I really can't think like a lot of things right now. Been a while ever since I did a Kotlin Java interop, but Kotlin's page has itself has a Kotlin interop section, Kotlin Java interop section that you can use.
Yeah, okay, thank you. Just wanted to ask you, like, can you just let the audience know, like, what they can expect next in the series, and what you will be talking about, so that they will be in touch and.
So yeah, so the next thing would be more about like more of these ideas. So the ideas that we looked at or we were looking at today, these are things that you don't really have to wait for, right? Of course, I'll publish the slides and then let you know on my Twitter handle today, so you can go and refer to these ideas by yourself. So these are ideas that you can take and apply at your work. So the next session would also be more of these ideas that you can take and apply at your day-to-day work. And then probably we'll have a third session on mostly on testing. So if you've never tested or if you've never written tests, how do you go about writing tests? And writing tests is very, very essential to create software that is quite robust. So I think the final session would be mostly on testing. Yeah, so those are the ideas. So the second session will be more about like little ideas that you can go and apply at your day-to-day work, and the last session would be on testing. Hey, Archana, does that answer your question?
Yeah, yeah, definitely it answered. Yes, it gave more insights on what we can expect in the next upcoming series. So yeah, thank you, Raghunath. Thanks for sharing your tips and tricks on building a robust software, and also yes, we will be waiting for the next series, next session in this series. Thank you. Thanks a lot,
Thank
and
you, Archana.
also for all the audience who have shown interest and joined the session.
Yeah, thank you, folks, for staying with us till the end, despite all the technical problems that we had. And I would also like to thank all the Meet Katie folks, especially during times like this, to put this together. So right now you just see Archana and me like here on the stream, but it's taken like a large team to pull this off. It's not very easy. Like a lot of support from both Globant and JetBrains to bring this to you folks. Thank you very much. And thanks to all the organizers of Meet Katie. You folks are doing a wonderful job. Thank you very much.
Thank you. Okay. Thanks, guys. We will be ending the stream right now. Thank you.